Welcome. Today, we're going to pull back the skin, literally, to look at one of the most widespread and honestly misunderstood parts of the human body. It's this powerful, super versatile, and often invisible framework that holds you together. We're talking about connective tissue.
All right, let's just jump right in with a quick pop quiz. If you had to take a guess, what single type of tissue makes up most of your body? Go on, I'll give you a second to think about it.
So, if you guessed muscle or maybe skin or even bone, you're in good company, but you'd be wrong. The answer is connective tissue. It's the biological fabric that binds, supports, and connects pretty much all our other tissues and organs. And to see just how diverse it is, we're going to go on a little journey into the human arm.
Yeah, that's right. Just by exploring this one part of the body, we're going to uncover a hidden world of different structures that seem totally unrelated. But believe it or not, they all belong to the same remarkable family.
So as we peel back that first layer of skin, we immediately run into our very first example. So this right here, this is adipose tissue, what most of us just call fat. But it's not just sitting there. It's actually a type of loose connective tissue that forms this protective cushion around our organs. It insulates us from the cold, and it keeps it really vital reserve of energy ready to go when we need it.
Okay, now let's go a little deeper. You see that thick, white core that's anchoring the bicep muscle to the bone? Well, that's a tendon. It's forged from this incredibly dense, white, fibrous connective tissue. Basically, tightly packed bundles of collagen that give it incredible strength to translate all that muscle power into actual movement.
And what about at the ends of the bones, where they meet at the elbow joint? They're capped with this smooth, almost glistening substance. That's cartilage. It's a tough but flexible, supportive connective tissue that lets your bones glide right past each other without grinding away. And you guessed it, this is also part of the same family. Kind of surprising, right?
And that brings us to our next example, which might just be the most foundational one of all. The bone itself, the solid framework giving your arm its actual shape, is also a type of connective tissue. It's just a really specialized, mineralized version that provides the main support and protection for our entire body.
All right, for our final stop, we've arrived at the most surprising member of the family. Flowing through vessels within all these other tissues is blood. Yep, blood. It's considered the body's only fluid connective tissue. It's our internal river responsible for transporting everything from oxygen to hormones. So just think about that for a second. Fat, tendons, cartilage, bone, and blood, all found in this one arm, and they're all part of the same connective tissue family. Wild.
So, this raises a pretty big question, doesn't it? How can things as wildly different as solid bone and liquid blood possibly be part of the same tissue family? I mean, what's the secret blueprint that ties them all together?
Well, the answer lies in something called the extracellular matrix. Think of it like this. Most tissues in your body are like a brick wall, with the cells packed tightly together like bricks. But connective tissue, it's more like Jell-O with fruit scattered inside. The Jell-O is the matrix, and the fruit pieces are the cells. It's basically living cells scattered within a whole lot of non-living material that those very cells produce. And here's the crucial part, the thing that makes it all click. The properties of any connective tissue. They're not determined by the cells, but by the matrix itself. In blood, that matrix is a liquid. It's plasma. In cartilage, it's a firm, flexible gel. And in bone, the matrix is rock hard and calcified. So, the cells are like the architects, but the matrix is the building itself. And this shared blueprint, this really simple idea of cells floating inside a matrix, it allows scientists to organize this huge family into three main branches. You've got the proper tissues, like fat and tendons, the supportive tissues, like cartilage and bone, and the fluid tissues, which are blood and lymph. It's actually a super elegant system for organizing so much variety.
So now that we kind of get the blueprint, let's just step back and look at the incredible range of jobs this one tissue family performs for us every single day. It is without a doubt a truly versatile toolkit.
Okay, so let's just run through this incredible resume, right? It binds tissues like the skin to the muscle in the arm. It forms your entire framework with the bone and cartilage we just saw. It protects your organs. It stores energy in that adipose tissue. It insulates you. It transports everything from oxygen to hormones in the blood. And it even defends you from infection with cells that are found in blood and lymph. I mean, it's absolutely staggering what this one group does.
So it's pretty clear we need to think of connective tissue as way, way more than just the body's simple glue. That description just doesn't even begin to do it justice.
It's so much more than that.
It's a major supporting tissue, and it's described as a complex mix of different cells, fibers, and that all-important matrix. In other words, this isn't passive stuff, it's an active, dynamic system.
So let's try to reframe our thinking here. Connective tissue isn't just glue. No way! It's the body's internal scaffold, its emergency fuel tank, its protective armor, and its transportation superhighway, all rolled into one incredible tissue type.
And you know, that really leaves us with a final thought. If one single tissue family can be responsible for so many critical and different jobs, it just makes you wonder, what other amazing, complex biological systems are hiding right there in plain sight, just waiting to be understood?